setting up information, which I should have online by the end of today, to do about your midterm exam. So keep an eye open on that. We'll probably talk about it in detail tomorrow once it is up and running. But essentially, there's going to be a new module in Canvas. It'll be called midterm exam, something like that. And inside that, I'm putting everything that you need. So that'll be instructions about what you can do and not do. I've already got a practice midterm up online, just floating around, so you can have a look at a previous midterm with solutions, so you get an idea of what that looks like. But sometime later this evening, I'll have that kind of formalized and put in one nice package. So keep your eye open for it. So let's begin. We're starting a new section, 6.4. There is, as they like doing in this book, some overlap. So we're going to look at finding exact values for inverse trig functions. That's the first thing. And then we're going to find inverse trig function values using our calculator, which is going to be a lot easier. And then we'll go on and do some of these other topics. So if I asked you to find the inverse sine of square root of 2 over 2, and you want an exact value, you use this guy. Now, one of the things that you just have to be aware of is that there is only one answer to any inverse sine, cosine, or tan, actually. That should say tan. Or tan inverse function. There's only one value. So the way that you find out which one of the many choices it could be is to follow the range. So the inverse sine of the square root of 2 over 2 is an angle. It's an angle that has to be in this range. That way you only get one answer. And it has the property that it has a sine of root 2 over 2. So I'm going to look at my unit circle. I'm going to look for y coordinates that are equal to that guy, but they have to be between negative pi upon 2 and pi upon 2. So essentially they have to be here, right? So as I go hunting for it, y coordinates of root 2 upon 2, would you agree that one has a y coordinate? And that angle is pi upon 4. Agreed? Right. And so that's the one I want. So the answer to what's this equal to? The answer is that one. So when you are looking for inverse sine functions, only look for guys in this range. Right? That's how you make sure you get the one answer. Because there are actually two answers that could be true, but only one of them is actually the one that we're looking for. So if I can move on to the next one. If you want to find an inverse cosine of, say, root 3 upon 2, well, what you're looking for is an angle, but this time your angle comes from there, from 0 to pi upon 2. And what does a cosine get you? Well, isn't that the y coordinate? The x coordinate. So I'm looking for an angle whose x coordinate is this guy, and it's in this range. So x coordinate of root 3 upon 2 is pi upon 6. So the answer to the inverse cosine of root 3 upon 2 is pi upon 6. Right, I'll do that one in a minute. Let's just do some more quick practice at these. So I want to find the inverse sine of root 3 upon 2, put a little negative in it. The inverse cosine of negative 1/2, right, that would be a good one. Inverse sine positive 1/2, right? So there's 3 more guys. Now, when you're doing a sine, your answer is going to be in that range. So I'm going to look at these 2 guys. I'm going to look for a y coordinate that looks like that. And that is this one here. Now, the mistake you're going to make, and it's pretty obvious why you would do it because it seems reasonable, is you would write down the answer, which is 5/3 pi. I agree that seems reasonable, but it's not right. Because the way we measure the angles in inverse trig functions is we measure them from negative pi upon 2 to positive pi upon 2, which means you have to figure out what does that guy look like if you went this way, right? That's the negative direction. So what answer do we actually use instead of 5/3? Negative what?
Pi over 3.
Is it 1 or 2? Pi upon 3, agreed? Yes. And you stick a negative in front of it. So that's the little hiccup, right? I know we did this before, but I try to emphasize more than I think I did last time, that there's only one answer. And if it's an inverse sign, it has to come from here. And if your angle's up here, you use the one you see. And if the angle down here, you use the negative equivalent. Now, if I'm doing a cosine of -1/2, then I am looking for an x coordinate equal to -1/2. So here we go. And an x coordinate of -1/2 is this guy here. Now, when you do a cosine, it's these two quadrants that you get your answer from. So they're a lot easier, isn't the one you see is the one you use, right? You don't need to do any conversions. It is 2/3 pi. Okay, I'm going to do an inverse cosine of 1/2. So I'm looking for an angle whose y coordinate is 1/2. So far, so good. Now, for a sine, will I get the answer from these two quadrants, or will I get the answer from these two? Which one do you use when it's an inverse sine that you're looking for?
First and fourth.
Great, everyone. Right, just get into the habit of remembering, which quadrants you get your answer from. Now, I'm looking at this guy, and it's this fella here, and I'm looking for a y coordinate of 1/2. So, whoops, pi upon 6. We are good to go. All right. Now, it's a little bit messier when you do inverse tans, which is why I kind of skipped that one. So let's do an inverse tan of 1. Now, to get the tan, don't you do a y coordinate divided by an x coordinate? And when it's a tangent, the answers are in the 1 and 4 quadrant, right? So I need to find an angle whose y coordinate divided by its x coordinate is 1. Can you see any angle in either of these two quadrants where that's true?
Pi over 4.
Pi over 2.
Pi over 4. Agreed? Pi over 4. Check it. Y divided by x. Do you know when you're doing these things, because the bottoms are the same, can't you just ignore them and just say √2 over √2? Isn't that a little bit easier to find? So if I was going to do this one, wouldn't it be √3 over 1, which is √3? And if I was going to do this one, wouldn't it be 1 over √3? Isn't it a lot easier to do them when you don't have 2's to worry about, right? Just pretend the 2's aren't there because they're going to cancel out. So this pi upon 6 would be a 1 over √3. This would be √2 over 2, which is 1, and this would be √3 over 1. Now, what would you get if it was -1? So still in these quadrants.
Pi over 4.
You nailed it. That makes sense? Why it's negative?
I just have a question.
Yes.
So I know sometimes we do use the negatives and sometimes we don't. So what are the rules for that? When do we do the reference angle and versus the, do you know what I mean?
If you're doing an inverse sine, cosine, tan guy like we are right now, then you will do the plus minus angles like this. If you're talking about questions like, I'm trying to think of a question like that. If someone says to you the sine of 5/6 pi or the sine of negative 1/6 pi, right? If they ask you a question like that, don't you just find the angle in the range 3 or 360? So in those situations, you would just use wherever that angle is. Now, if they gave you an angle that's not in the unit circle, then you'd have to do its reference, right? So if you were doing an angle like sine of negative a quarter pi, wouldn't that be this guy here? I don't know if I've answered your question, but if it's an inverse trig, you're going to use plus and, you're going to use either those two quadrants or those two quadrants, right?
Okay.
So
Thank you.
that's an easy one. The other one, it depends on context, I guess. Let's try this one. Okay, so I'm looking for a y coordinate divided by an x coordinate that's equal to that guy. And it has to be in these two quadrants. So where would you get an inverse? Where would you get an angle whose y divided by its x coordinate is this guy?
Negative pi over 6.
Agreed? That's the angle, but that's negative 1/6 pi. So I think you're comfortable about using the inverse sines, cosine, tan. Agreed? Is there any questions about these, or are we good? You want to see some more examples? Yeah.
So my only question is for tangent, the inverse of tangent. Do you just get it from quadrant 1 and 4, or is it 1
Correct.
and 2?
1 and 4 for tangents, inverse tangents. 1 and 4 for inverse sines. 1 and 2 for inverse cosines. I wish it was the same quadrant for all three, in which case we wouldn't have such a awkward rule, right? But it is different. Inverse sines and tans. Inverse cosines. Okay.
Your notes on the bottom of the unit circle say 1 and 2 for a tangent.
Oops, thank you. Now fixed. Are we good? Right. Let's show you the next group of questions, which is how do you do it using your calculator? Well, if I find my calculator, I'll show you. Can't be far. Here it is. Now, I believe that sometimes the questions are degrees and sometimes the question are in radians. And so let's just do them in radians and assume that if they don't mention degrees, that by default, the angle that we're going to get is radians. So I would like to get an inverse sine of something. So inverse sine, and let's say I want to find the inverse sine of 0.5. There's your answer. Do you want an inverse cosine of negative 0.35 radians? There's your answer. So these are radians, right? That's about half a radian. That's about 1.9 radians. If you do an inverse tangent of negative 25, because tangents can have values like negative 25, you see the answer is negative 1.5. So you don't need to worry about which quadrant the answer is in, because doesn't the calculator know what quadrant it is, and it tells you the right answer. So you notice how this one is negative 1.5 radians and so on. Now, if the answer was in degrees, which it might be, let's show you, switch over to degrees and then do second quit. And so I would like to get the inverse sine of 0.5. And the answer to what's the inverse sine of a half is 30 degrees. And what's the inverse cosine of negative 0. Whatever that is? The answer is about 104.9 degrees. And if you want an inverse tan, The answer is about negative 87, 88 degrees. So actually, if someone says to you, find and round off, because you have to round these answers off, any of these inverse trigs, would you agree that they're pretty easy? Right? Calculator does all of it. You just type in inverse sine, cosine, or tangent. So far, so good. Right. Now, there are three inverse trig functions that you hardly ever use, but for completeness sake, I'm going to show you how you would do them. Suppose someone went and said, suppose someone said, I'd like the inverse secant of 2. Now, actually, you could use your calculator, but I'm not even sure where it is. It'd be hidden under catalog, but I'm not going to do that. What you're going to do is you're going to turn it into its equivalent partner. You remember cosines and secants, like husband and wife, right? Thing they go together, right? What is this going to be here then? What will that 2 turn into?
1/2.
And so all you do is find inverse cosine of 1/2, and the answer is 60 degrees. And if you're being asked to find, if you're being asked to find the inverse cotangent of 23, who is the partner of a cotangent?
Tangent.
Tangent. So you will find the inverse tangent of 1/23. Does that make sense? And then you can go to your calculator and do inverse tangent of 1 divided by 23. And the answer you'll get is, since I'm in degrees right now, 2.4. Now, if I was in radians, wouldn't I just be writing down what the radian answer was, right? I would still do exactly the same thing, right? Same thing, different answer. Put in a negative. Suppose I wanted to find the inverse cosecant. Right, who's the partner to go with? Cosecant now.
Sine.
Sine.
Okay, so we're going to go inverse sine of 1/that guy. Now, since it's all going to be done by calculators, I don't care how ugly that is. I just do inverse sine 1 divided by negative 3.12, and the answer I get is, in this case, negative 18.7 degrees. Are you comfortable about how to find these guys? They're pretty rare. They don't ask you them very often. But how?
Sorry. So like with like the negative equivalent when we did like with the unit circle at the beginning, do we have to do that same type of math with the ones with the calculators or no?
No, calculator figures it all out for you, which makes your life so much easier.
Okay.
Whatever number the calculator gives you is the answer. You don't need to tweak it or twist it around or change it, right? Whatever it gives you is the answer. You just have to make sure that if you want degrees, then it is degrees. But if you want the answer to be radians, don't you have to make sure that you're in radians?
Yeah, if it doesn't say, do we just do degrees?
Assume it, no, if it doesn't say, assume it's radians. That seems to be the default in this book. If they don't say anything, it's radians. If they want it to be degrees, they will hopefully tell you it's degrees. But if you get 5 guesses, won't you know if it's not the first one, you can always do the other one. I think that's went relatively okay. But, you know, I'm only judging by faces and things. So if you want to find inverse trig functions using your calculator, is that okay? Do you feel comfortable about the buttons you need to press and where to get them? Okay. So we're now going to move on to kind of deja vu. How to find missing angles in right angle triangles. So here's a triangle. I'll make that 7. I'll make that 15. And I want to know angle theta. Well, hopefully a lot of what I'm about to do is what you would have done even if I hadn't mentioned it. First thing I'm going to do is name this side the opposite, and I'm going to use that side as hypotenuse. And I'm going to just write up socket over here. Because in this question, I know these two. Right? All I need to do is find this fella. Which one of the 3 trig ratios uses an opposite and a hypotenuse?
Sine.
And so you will do the sine of theta is the opposite over the hypotenuse. You will do the sine of theta is 7 over 15. So how will I find angle theta?
The inverse.
The inverse sine of both sides.
Agreed? And then make sure I'm in, what do they want here? I'm having a quick look here. Ooh, you little buggers. That's not nice. I'll show you in a second. Oh, it is nice. For a moment, I thought they didn't tell me that the answer had to be in degrees, because I saw the answer was in degrees, and I'm saying, oh, but they did. Okay, so they are asking it to be in degrees, so I'm going to go to my mode, and I'm going to go in degrees, which is fine. And so now I can do the inverse sine of 7/15, and they want the answer to 1 decimal place. So to 1 decimal place, the answer would be 27.8 degrees. So now don't we have a nice easy way, using a calculator, to find the missing angle in any right angle triangle. Great. So suppose I give you a triangle and it's, oh, yeah, I can do it this way. And it's pointing in that funny orientation. And this is 11, and this is 5. And we're being asked to find the size of angle theta. So in this question here, what name will I give to the side that's 5 units long?
Opposite.
Right. So from this angle's perspective, here is the opposite. Would you agree that this one here is the adjacent? Looking good? Opposite, adjacent. Now, which one of the trig ratios uses opposite and adjacent?
Tangent.
So you would set it up as the tangent of theta is the opposite over the adjacent. At least you would do this in a test. And that would be 5/11. And to get theta then, wouldn't we take the inverse tangent of both sides? Okay, so far so good. Now, on my calculator, inverse tangent in degrees of 5/11 to 1 decimal place is 24.4 degrees. So I'll draw another version of that same picture. I now know that this is 24.4. Gotcha. I know that's a right angle. I know this is 5, and I know this is 11. how would I find this angle here? And think of the easiest way to get it.
90 minus 24.4.
Agreed? 90, take away that number, what's left? And how would I get that side? Again, think of the easiest way to do it.
Diagrams.
Yes. Right, now, I could have got that using SOHCAHTOA, but I think that's a bit complicated, isn't it? There's a lot of stuff to do. Pythagoras is cleaner. So we really can do anything you could possibly think of to a right angle triangle now. As long as I give you two sides, can't you find all the missing angles and all the missing sides? Don't matter what the right angled, only right angled, of course. Doesn't matter what the right angled is, we are able to do it. Oh, by the way, in some of the earlier questions, that's the answer. You just write inverse tan of 5/11. So they don't even ask you to do that step. So what question did that? Because I saw it a minute ago. Question 1 does that. Right. So if when you look at question 1, they just ask you to fill in what they only ask you actually fill in that little piece, because that bit's already, you just fill that in. That seems a bit pointless, but they can do it. Are we good that if I give you a right angle triangle and tell you two of the sides, are we good that you could fill in the size of the missing angle and everything else if you were asked to find it? You feel good about that? Want to see more?
I think we're good.
Okay. Now check. Now this one here is, oh God, I can't think of a phrase for it. Weird? Strange? Yeah, let's call it strange. These are kind of strange questions. Here's an example. Question 14 says, find all the angles. This is going to bug you a lot, Katie, so I'm warning you right up front. Be ready to be confused. Plus, it is going to sound like I'm contradicting what I said, but I'm not actually contradicting what I said earlier today. It's just you have to adapt. So here goes. Find all the angles, and this is the bit that makes them weird, between 0 degrees and 180 degrees, satisfying the given equation, and round it off to 1 decimal place. So here it goes. The sine of theta is equal to 1/3. Right? No problem here. We're looking for all the angles between 0 and 180 where this is true. Now, to get one of those angles, wouldn't we do an inverse sine of 1/3? You're with me so far, right? So I'll go to my calculator, it's in degrees already, and I will do the inverse sine of 1/3. And the answer I get, if you round it off, is 19.5 degrees. And that would be this guy here. Now you notice that this guy is in the first quadrant. Now I want you to forget about inverse sines and what quadrants you can get the answers to. And now we're going hunting for another angle who would give you a sine of 1/3. Now it's a positive number. So which quadrant?
2.
Would you agree there's another angle in the second quadrant? Remember those reference angles that Katie was talking about earlier? This is where these guys are kicking in, right? Now,
Would it be 160.5?
you nailed it, yes. Is that beginning to make more sense when you see the context, right? So the second angle, this is this one here. That's the angle that I'm trying to get. And what we know is, I don't know why I'm doing this dotted, but I am, right? That there's another angle over here that makes the same size, right? It's called the reference angle. So if you use this and this guy, can you see that the one we want is 180 take away 19.5? So, which is 160.5 degrees. Do you see how these guys are weird? Right, what I'm talking about. They're not asking for the inverse sine of a third. If the question was, what is the inverse sine of a third? Wouldn't there only be one answer and it's 19.5? Agreed? That if they asked you, what is that? Right? But this is a different question, right? You're starting off with a sine of theta, and you're being asked to find as many angles as exist in that range. Now I'm going to do that same question again with one change. Now you notice the one change I've done is the range that you're allowed to pick. So we want all the angles between 0 and 90 that solve this problem. We already know that answer. What angle works?
19.5.
Why am I not adding in the 160.5 this time?
Because it's out of range.
It's out of range. So do you see the question depends on what restrictions they put on your answer, right? We good? Right. Show you another one. Let's put in a negative one. I want to find the solution to when is the cosine of theta equal to negative 0.313, and I'm allowed to pick anybody in the range 0 to 360 degrees, okay? So that's the range I can choose from. Now to get theta, I'm going to do the inverse cosine of that guy. That doesn't really change. So I'm now going to do inverse cosine of negative 0.313. And the answer I get is 108.2 degrees. I'm going to draw that guy, roughly. He's in the second quadrant, and this angle here is 108.2 degrees, and that's the second quadrant. Now that is correct, but there is another angle who also is has the property that its cosine is negative 0.313. Which quadrant do you get a cosine that's also negative? Which?
Three.
All right. Now I'll do my little dotted line guy. And the angle we want, right, is that one, right? In the third quadrant. Now it's a bit messy, this. that angle is 108, but this angle here is important, isn't it? How big is this angle from there to reaching the x-axis? Right, that's 108.2. How big is that angle?
71.8.
And for those who are not sure where you got that, you want to tell us?
Yeah, just subtracted 108.2 from 180.
Yeah. Now, the symmetry in the unit circle is that this angle here and that angle there are the same size. So this angle from the x-axis to here is the same as from that to here, which makes this one here also 71.8. Now there's enough here, if you think about it, to tell me what the angle is starting here at 0 and going all the way by the x-axis and down to here. How big is that second angle? What's its size?
$251.8.
Okay, and what you're doing is 180 plus that guy, which gives you 251.8 degrees. So you see how strange these questions are, right?
Wait, are you able to just subtract 108.2 from 360? Does that
You
work?
are. You can. Did you see what she just did there? It's a cool way of doing it. If that's the first guy, if you take this away from 360, don't you get that guy? So I will put that in. It's 360, take away that guy, also gives you 215.8. What made you think of that? Because it works.
I was just skipping steps. I
That
just
skipping
didn't want to
steps,
do all the...
it's called being efficient, right? Nothing wrong with skipping steps. This trick that you've just used works really, really well for cosines. Unfortunately, not so well for the other two. So I wish I could say, oh, I'll just do that all the time. For the cosine, bang on. It's a really short way of doing it. For the sine and cosine, it's a little bit trickier. And for actually, if you want to have a rule for the sine, don't you take 180, take this away from 180. So a little bit different rule. And for a tangent, it's similar to that rule. Okay, let's try one with a tangent in it. We want angles in the range 0 to 360 again. Oh, by the way, in that previous question, the one we just finished, if I'd said 0 to 180, right? If I'd said, give me the angle from 0 to 180, wouldn't we only have given the first one? If I'd said from 180 to 360, wouldn't we only have told, given the second one, right? So you can certainly find both. It's probably a good idea to find them anyway, and then decide, do they want me to put both down or do they only want me to put one of them down? So let's do a 0 to 360. We're going to do an inverse tan of 5. And I just screwed up that question. It's going to be 0 to 360. And let's do the tan of theta equals 5, right? Let's get it in order.
Wait, before we move on from the last one, I have a question.
Sure, what you got?
So it goes from 0 to 360. So wouldn't there be 3 possible, or?
Oh, would there'd be another, well, any of the others that you might create wouldn't get you positive answers or negative answers, right?
Oh, so they have
There's-
to. Yeah.
They have to be the same sign. So when you're in a unit circle, as isn't there going to be two places where the answer is positive and two places where the answer is negative? So the most you're going to find is two answers, right?
Oh, okay.
Does that make sense?
Yeah.
Okay. So we are looking for inverse tan of 5. I'll go here and I'll type in inverse tan of 5. And in this case, the answer ends up being 78.7 degrees. And because I'm a kind of visual person, it helps me at least to draw a very baby sketch of it. Which quadrant is the other quadrant that has a positive tangent?
4.
3.
You all agree? Third quadrant. Now, this angle in here, isn't that angle also 78.5? Because angles make the same angle with the x-axis, right? Equivalent angles make the same angle with the x-axis, right? So, okay, so what is my second one? How will I get?
You can add 78.7 to 180.
Agreed. And that gets you 258.7 degrees, I hope. Suppose the question had only been 0 to 180. What would I have as my answers? Would I give both or would I give one?
Just a 1.
Just the one. And if they had decided to go 180 to 360, wouldn't the one be this one? So make sure that you read this guy up here, because sometimes you just forget and give two answers every time, when there may only be one answer because of the, the range that you've defined it in.
I have a question.
Yes.
How come it's different from the range?
In other words, the angles you got, both of them are not in the range they ask you. Like they might ask you, what, 270, 360, for instance. Right? In which case the answer would be no solution. There are no angles in that range.
Yeah, but like when we were finding the inverse tangents and we said the range was in quadrant.
Oh, okay, let's show you one that's happening. Let's do the inverse tangent of 1. I'm picking the nice easy one, right? So I should start off with a question. The question would be, let's just start again. I'm always one line ahead of myself. Right, let's suppose we're being asked to solve that guy, right? And we'll make it -1 to make it more interesting. And we'll do a complete circle, right? Now, theta is the inverse tan of -1. Now, when you do the inverse tan, something annoying is going to happen. So I'm glad you brought that question up. You are going to get an angle of -45 degrees, which is what you'd expect, right? It's in the fourth quadrant, right? Remember these two guys? You're going to get this one. So we have to adapt. We only want answers in the unit circle, right? 0 to 360. Now, if I draw -45 degrees, would you agree it's pointing down that way? Technically, it's that answer, right? So here goes. Isn't it also the same for the purpose of this question, the green way? So what is that green angle, which is the same position as -45 would get you?
15.
Okay, so what? 360, take away 45, for those who are wondering, 315 degrees. So do you see I've now got an angle that is in the range they're talking about. I just have to figure out what angle is the same position as negative 45. So that's good. And that is in the fourth quadrant. But we still have typically two answers, right? Which quadrant is the other quadrant where a tangent is negative?
And 2.
If we do where that would go, wouldn't that guy be up here? And if we use the fact that this is 45 as well, can you see that we can now get the other one? And what is the other one going to be? What is the size of that angle?
135.
Right. Does that answer your question about what do you do if it's not in the range? Is that the
Yeah.
kind of thing you were thinking about?
Yeah.
Right, so that's what you do. Has anybody seen a little shortcut for getting this angle?
90 plus 45.
Okay, that works. Or 180 take away 45, that works. Can anybody find this one? Isn't this 360 take away 45 and this is 180 take away 45? Do you see? I mean, once you've done a few of them, can't you figure little shortcuts? I can't remember who it was, but didn't one of them wait and said, couldn't I just take the answer away from 360 and get the second one? Remember, for the inverse cosine situation. Once you've done enough of these, you'll find little patterns that kind of make your life a little bit quicker. Me, I just draw pictures because I'm a visual person and it works for me. Right. So I draw where the first one is, and then I know which quadrant the other one is, and then we do it. Now, if they had just said 0 to 180, right? They might have said 0 to 180 here. If they had done that, wouldn't the only answer be 135? If they said from 0 to 180, that would be the only answer I would choose because the other one's too big. And perfect timing.